All right, looks like we reached critical mass. Let's go ahead and get started today. Thanks again for everybody joining us on today's webinar, Harnessing Earth's Power Using Geothermal. Today with us, we have Will Lang. He is the Director of Utility Marketing for a company called Water Furnace. So he's going to dive into geothermal technology and what sets it apart from conventional heating and cooling systems. A little bit of housekeeping though. So as we all know, energy code continues to evolve. Heat pumps will be playing a vital role in reducing energy consumption, lowering greenhouse gas emissions, and reducing the carbon footprint of our houses and buildings. So with that, as always, we'll kind of spin through this. If you're new to Spear, kind of just an overview of what Spear can do. We provide training, webinars, in-person field trainings, as well as IECC test prep training for any of you that are looking to get certified through the IECC. I can help answer questions regarding energy code. ASHRAE 90.1 can help with questions from plan reviewers to building officials to third-party energy inspectors. Always happy to help in any way that we can. We assist cities with the adoption process of the 2021 and beyond. We help navigate through the additional amendments that are out there, as well as the 2024, what's coming out, what to look for as it goes through it. Also, just an enforcement and adoption of the 18 as well. So I'll be monitoring the chat and the Q&A sessions. Please feel free to post any questions you have there. If it's pertinent to what's on the screen and what Will's going through, then we'll go ahead and try to present that question at the time. Otherwise, we'll wait till the end to get to that. Lastly, as always, my contact information will be at the end of this presentation, so please feel free to reach out to me with any questions. Feel free to share my information with anybody that you think that would need our assistance and help with the energy code or discussing that. We've got a lot of, I've had a lot of phone calls from, excuse me, residential people that are actually looking to answer questions about buildings that are being built in the county. So as always, this is being recorded. It will be posted up to YouTube within about 72 hours. Also, Kathy Lawrence will be sending you a course completion evaluation survey. Please fill that out, return that to her, and she will get you a certificate of course completion that you can use when you're reporting your CEUs to ICC. So with that, I will see if we can get Will, are you online?
I sure am.
All right, sir. So I will stop sharing my screen and you're welcome to share your screen.
Okay, got it. Thank you, Randy.
You bet.
All righty. Let's see. Trying to share 1 second.
Yeah, thanks for joining us.
Okay. You bet. Absolutely. Randy, just double checking. How long would you like me to contain this to? Was it 50 minutes or an hour? Just
Yeah, that's fine. Then we'll have a Q&A session open as it goes through. It may we have to spur some questions that may take a little bit more time, but 45 minutes to an hour is fine.
okay, great. All righty. Well, good morning, folks. I'm just up here a little ways in Arkansas. Spent about 20 years in Texas, East Texas, and since I left there, I've discovered that it can actually be, you can move 300 miles out of Texas and get to 20 below zero. So I'm all about pumping heat these days. In any case, again, my name is Will Lang. I work for Water Furnace International. My logo's there at the bottom, along with the Spear logo. We're one of several heat pump manufacturers in the United States, and we are active in the state of Texas. We'd just like to go down a little bit of a rabbit hole on what ground source heat pumps are. They're not like other heat pumps, and I'm looking forward to your questions at the end. Randy, if there's stuff in the chat, I'll try to keep an eye out for that, and we'll just work our way through this.
Yeah, I'll be monitoring that. So if I find a break,
okay.
I'll bring up the question.
Great.
Yeah.
So we'll just dive in real quick with some of the topics that we want to cover today. We're going to cover technology and installation for those of you that are inspectors, what you can expect with a good heat pump installation, how they should be commissioned. I'd like to make sure everybody here gets a copy of these slides if they want to go back and do any homework, if they run across one of these. And what why would you even do this in the first place? How does it affect the homeowners, the utilities, the environment? And we'll talk about some broader topics there, and then we'll get into some specific technology updates. And perhaps most important to everybody here, we'll look at resources, things that are available to you to make things work better in your all respective jobs. Going to try to keep this up your alley for those of you that are building inspectors or HERS raters or just technology geeks. So we'll try to stay in that area. And some of you may already know a lot about this stuff, but if you do, forgive me, we're going to hit on these for everybody. What's in it for everybody? Hey, wake up, ERCOT. And then we're going to hit kind of really, I talked about technology, but mostly about the changes and how things are new. So let's dig into it. Why Texas? Is there such a thing as ground source heat pumps in Texas? Well, when it's this hot in Texas, and I remember last summer very well, it was pretty hot right up here, 30 feet below my feet, standing in my yard, the temperature was a steady 68 degrees where I am. And where you are, it would range as high as 72. And that never changes. Winter, summer, spring, fall, 30 feet below the surface, that temperature is constant. That's where we pump our heat to. It's where we pump our heat from. And when it's that hot, it's a whole lot easier to pump heat into 70-degree dirt than it is into 110-degree air. So that's what we're trying to do. And in the wintertime, this is actually Houston during Winter Storm Uri, which some of you remember. That was something else. People were cross-country skiing to HEB. It was still that very same temperature, 30 feet below the ground. Once again, if you're looking to pull some heat out of the ground, zero, there isn't much to pull out. But when it's 67 to 72 degrees, there's a lot of heat down there to pull out and pump into a building or a home. That's the whole principle of what we're trying to do here. Are there heat pumps and ground source heat pumps in Texas? Yep, there are a bunch. This map shows locations of heat pumps that my company has had installed where people have chosen to use our monitoring system. And we're watching all of those 240 heat pumps in Texas. Every 10 seconds, we're measuring all the electrical usage of every component. We're measuring the set points, the space temperatures, the static on the air filter, the pressures of the refrigerants, the temperatures of the in water and the out water. We know everything. We can do a complete troubleshooting job on those 240 units from a pickup truck in Paris, Texas, or anywhere in the world where you have internet access. That little chart on the right gives you an idea of what size heat pumps are typically used in Texas. These are ground source heat pumps. Just that sampling you're looking at, it's kind of an indicator. Most of them are 4 and 5 tons with a sprinkling of some 2, 3, and 6. But that's what to look for in terms of where they're distributed. There are many thousands more ground source heat pumps in Texas. This is just a small sampling. And the numbers you see on the bottom of that page are based on 12.5 cents per kilowatt hour electricity. So about $1.50 a day to run an average 4-ton heat pump in Texas for 12 months. All your heating, all your cooling, and most of your hot water. So here's some reasons why you would look at this in Texas. Resiliency when it's 110 or 15 degrees in Dallas, and it's been that way for day after day after day. The efficiency doesn't really go down with a properly installed ground source heat pump. It should remain about the same. The capacity does not go down. A 5-ton air source heat pump at 115 degrees, even when it's brand new, right out of the factory, perfectly installed, is only operating at about 55 or 60% capacity. which means your 5-ton at 115 degrees is about a 3-ton unit in reality. So when you need it the most, an air source heat pump is not providing what it needs to. Ground source heat pumps don't really feel that change in the air temperature because they're working with the dirt. And the life cycle is quite different. Ground source heat pump should last 25 to 30 years, according to the Department of Energy. We see at least that, and the loops underground should last over 100 years, well over 100 years. The loop that we have in our factory is approaching 40 years old, and we have not done anything to it in the last 40 years, except put a bunch of heat into it and take a bunch of heat out of it. So they last a long time and they're resilient to weather changes. Peak load. If I'm working at ERCOT, I'm thinking about this a lot. I'm thinking about Winter Storm Uri and the recent winter storm, and I'm thinking about last summer. And what's occurring to me is that these things are dramatically less energy intense at extreme temperatures, using half as much energy to heat or to cool in the summer and 3/4 less than resistance heat in the winter. And that's quite a bit different, even when, especially in Texas, when more than 60% of the people use resistance heat for heating their homes in the wintertime. So if I'm looking at $9,000 a megawatt hour for electricity, per megawatt of power and electricity, that's a significant reduction for me as an electrical cooperative who has to pay that, or as somebody like Encore that has to produce that. And balancing the load is key. I mean, if I'm an electrical utility, I'm thinking about my seasonal balance, my daily balance, my winter versus summer peaking, my fuel stability. I don't want people switching back and forth from one fuel to another. I want to be able to predict the future, and I want a high load factor. I don't want to see major swings in the amount of electricity that people are using. In Texas, that's a very big deal. And some of you have experienced that. You've heard the stories from the extreme weather events. That's where these types of heat pumps, these ground source heat pumps, make a big impact. So recently, the federal government, in their legislative wisdom, passed a 30% tax credit for 10 years for residential and commercial ground source heat pumps with direct pay, meaning churches, elementary schools, independent school districts, colleges, privately owned, non-tax paying entities can benefit from this tax credit. Never paid $1 of taxes in the history of the existence of a church, for instance. They put in a $100,000 system, they can get a $30,000 check as a rebate for that installation. Yeah, I know that sounds crazy, but it's true. I see we've got some questions in the chat. Should I hold on there? Do you have anything we need to address right away?
No, I was just pushing out. Oh, actually, we do just have one that popped up in the Q&A. It says, has any ground source heat pumps been installed in South Texas, aka the Rio Grande Valley, that you know
You
of?
bet. Hundreds and hundreds of them.
Okay.
And I know where some of them are, and we can probably figure out where more of them are.
Got it. The other one was just me generally asking if anyone on the call was actually had a heat pump that they were using currently.
Good deal. So this is a quick update on some technology. Let's see, that's a wiring schematic. That's right out of our installation instructions. We have now, things have changed. We have color installation instructions you can pull up on your phone or your tablet without a password. Many dozens of pages of clear diagrams with wire colors and actual pictures of boards and things like that. Really come a long way since I started doing black and white installation instructions 30 years ago. You can see the typical heat pump there on your right. This one's a variable speed system with a variable speed compressor. You can see the control board actually hinges out so you can work on it. That's an upflow side return unit. And then down at the bottom, I mentioned we were monitoring those 240 heat pumps in Texas. That's an actual online screenshot of what we can see. And that includes all the pressures, temperatures, airflows, flow rates, energy usage, everything. I can tell you if you need to change your filter by looking at that. I can tell you if your loop is too small or if you've been running your electric heat, and I can look at that unit for every 10 seconds for the last 2 years and see that kind of information. So let's take a quick look at what I'm talking about here. I say a quick look. I can't seem to get the slides to advance. There we go. Commissioning, something many of you are involved with daily. We try to do extensive documentation so that people can look back in 20 years and figure out what they did right, and if there was something wrong, where that came from. So the future is dependent on what you do the day you install it. And that's true for any mechanical equipment, but especially with heat pumps. So first thing, we're going to look at water flow, pump watts, thermostat setup, cycle rates, everything that you would normally want to see. And all of that from charge to airflow is available online or right at the unit visibly as you're doing it. An interesting thing here is 95% of all ground source heat pumps are not split systems. When they're installed, the contractor never touches the refrigeration circuit. They're packaged units. The refrigeration system is all inside that one box. So an installing contractor should not be checking the charge or putting his gauges on it to make sure it's okay. It's been charged precisely within 1/100th of an ounce by a computer. And it really, 95% of the time, it's not a split system, and nobody should be tinkering with the charge because we can measure that with the document or the instruments that are already on the unit. So that's a big difference for most installations from what you see every day in Texas with the chop and drop installations and replacements. No more need for putting your hand on the suction line to see if it's as cold as a Budweiser on a hot day. Oh, this is what a commissioning sheet would look like. These are provided with every unit in the installation instructions. You want to put down the serial number, model number, get all that recorded. It looks like this when it's filled out. There's the installation instructions on the right. Just very straightforward. They come with the unit, and a proper installation would have all of this information on there. That's what makes a unit last 30, 40, 50 years, is this proper documentation and measuring everything at startup. So, you see that handwritten notes, that is the old school way. We're now seeing, the kids with the phones want to do it the new school way. Well, everything's changing. We've got tablets. We no longer are doing things with blueprints. We do it on the phone. We can do it on a tablet. We can do it on a laptop. But this is how it looks these days. Oh my, okay. There's a process that walks you through this. I'm just going to click through this real fast, but the online app steps you through all this. You don't need Wi-Fi access. You just need cellular access to do this. The app is free to install, and it just walks you through every step of the process, what wires to connect to what terminals, what all the measurements should be as you go through it. And in the end, this is what you get on your app. It tells you exactly what's going on in every part of the system. Probably a good time to stop and check and see if there's questions.
Yeah, Will, just real quick, what you just went through a second ago, that's what the technician installing or the installer would actually be going through for commissioning the system. Can you talk just briefly? I know you and I spoke about this. Talk briefly about how extensive that technician's training is just for water furnace?
Well, we like to give our dealers a 3-day training class it's full 8 hours a day training class. That's ideal. A dealer, an experienced HVAC technician can do all this with just 4 or 6 hours of training. And we do have online training. We do have in-person training. We've got lots of opportunities. Uh, we could easily get an experienced technician up to speed on this in a 1-day online training class. It's very hands-on. We do it in Texas. We do it in the factory, um, and that can all be certified. As a matter of fact, to purchase our variable speed equipment, like most manufacturers, you have to have variable speed certification. And there's a guy online, Brian Shaw, I see him in the chat, who works in Texas and helps dealers with this every day. Just got back from a dealer's office, I think, a few minutes ago, helping him with this sort of information. So
Yeah,
lots
perfect.
of options for training.
Yeah, Brian actually posted the residential dealer locator link on the chat as well. So I appreciate that, Brian.
You bet. Thank you.
Mhm.
All righty. We'll skip ahead. I didn't want to get way down into the weeds on commissioning. We can answer technical questions, most of them, if anybody has one. But I don't want to get into the green wire and the orange wire. Quite not here today. We can later if we need to. Um, how would a ground source heat pump affect the homeowner's utilities and the environment? I mean, that's really kind of the key here. If I'm a homeowner, it's going to be probably more expensive than a typical installation of a furnace and a heat pump, or a furnace and an air conditioner. Not necessarily. When you factor in the tax credits and the rising cost of conventional furnaces and air conditioners, and the 14 SEER and the SEER 2 and some of the furnace efficiency standards, a 96% furnace with a 20 SEER heat pump or air conditioner can easily cost more than a ground source heat pump installation. So it can be higher. I don't want to mislead anybody, but it can be about the same. With the tax credit, it can very easily be the same. And in some cases where you have electrical cooperatives or utilities with rebates for ground source heat pumps, they can actually cost less. If I live in, say, South Carolina, which none of us do, they're 55% tax credits total, and rebates of $6,000, $7,000, and $8,000. So by the time you install one of these in South Carolina, it's actually less expensive than a regular alternative. So, puts and takes. It depends where you are in your utility company and your appetite for tax credits. The biggest impact for a homeowner is annual energy usage savings, and they are big. So installation cost may be higher, energy usage costs will be lower. That picture there is of what we call a horizontal loop. Somebody in Texas might have an acre or so of land, maybe even just a half an acre. If you can go out 400 feet, dig a ditch, you got plenty of room for what that is right there, a horizontal loop. And that's perfectly fine, say 8-10 feet deep in the state of Texas. Whether you're in El Dorado, up on the Llano Estacado, or down in Houston, Texas, that would work just fine. Homeowners' energy savings. Let's see, this is a house. Yep, I used to live in this house in Tyler, Texas, a long time ago. Converting that house from a gas furnace and a 14 SEER air conditioner would save $2,820 a year. And you can see most of that savings is going to be in cooling, and some of it will be in heating. A key thing to note is part of that savings, $382, is that system has a de-superheater on the compressor, which pumps hot water into your water tank. So you're saving energy on your gas water heater. So that's a real measurement. How do we know that's true? Well, we've got predictive software that sizes the loop and the equipment that works with the manual J. And then afterwards, that monitoring system you saw actually can compare to what we predicted. And we're finding they're within a few percentage points of each other. So I can predict what the installation will do before you do it, and then I can check it afterwards. And those numbers reflect what you would find as a result. Yep, I even got the fancy green circle on there for you. So let's try another house. Let's see. Let's go into Plano, Texas. Let's zoom down in a little bit to a neighborhood. Does that look like Plano? Does to me. Could be Madisonville. Could be, South Tyler. It could be Houston. It could be just about any of the cities in Texas. Could even be Laredo. But this one happens to be Evergreen Drive in Plano, Texas. Right here, I grabbed that house off the map and number 2300. And you can run this through that savings calculator up there. And to be fair, all of our competitors, whether it's Water Furnace or another manufacturer, they have savings calculators just like this, almost the same software. And we can go down and Google into that guy's living room just about. And we can find out that that house in Plano, kind of a typical 4-bedroom house, be about $2,600 almost in annual savings. And we can go back after that installation, as I mentioned, and confirm that with actual savings. Very similar to that house in Tyler. So if you wanted to do that, it's real simple to just go online and click that link and do your own house, which is kind of fun, actually. What's the impact to a utility? It's the highest efficiency solution. It's all electric, meaning that there's no combustion on the site, which can be an impact for homeowners. And not in Texas, but in the Northeast, that's becoming a big issue with zero on-site combustion. We'll talk about that a little bit later. And utility likes things that are long-lasting and require very little maintenance, and that don't change or decline in performance over time. So that's a key impact, really, for both the homeowners and the utilities. I wanted to show you this one technology back in 1985. That's the headquarters office for my company up in Fort Wayne, Indiana. About 20 below zero, the pond is frozen. And like every other industrial facility at every other industrial park in the United States, you have to have a stormwater runoff catchment basin, some sort of a stormwater runoff system. And in a flat, low-lying place like Indiana, or maybe even Houston, that pond can be full of water. So what they did when they built this facility, they built the pond so that it could withstand 12 feet of water 12 months out of the year, about 2.5 acres. And we've put a 300-ton load on that pond since 1985, since the day the ice melted and that loop you see there sank to the bottom of the pond with cinder blocks attached to it. That's been heating and cooling that building ever since, whether it was 100 degrees or 20 below zero. And there has been no maintenance performed on that underwater pipe network since. That is a thriving pond full of fish and ducks and geese, actually quite a few more geese than we'd like. You can ice skate on it in the winter and you can swim in it in the summertime. It's not any kind of a biological freak because of the 1 or 2 degrees that it changes when it's being used to its maximum. What an interesting thing, and this doesn't really apply in Texas, but when it freezes over, it really improves the heat transfer to the loop, because the heat coming from the center of the earth radiating upwards is trapped in the pond by the ice. So as the water circulates by the convected heat, it's a very good heat exchanger when it's frozen over. That's weird. I said, what? When I first heard that too. But the moral of the story is our thermal expenses in that factory are less than half, closer to a quarter of what our neighbors in that industrial park spend to heat and cool their buildings per square foot. So, you know, this is a repeat slide. I don't want to go into that. Recently, the federal government released this GeoVision report and discovered that we could reduce the size of the grid, today's grid in the United States by 33% with mass deployment of these types of heat pumps. Now that might be good news for a grid that's looking at a whole bunch of electric go-karts running around the highways. So this is one way of offsetting that potential outcome. Now, I'm a skeptical guy, and this is the very first thing I said when I first moved to Arkansas about 12 years ago. I said, you know, all our electricity here is made out of coal, most of it. Now it's less than half. But I said, why would you want to run an electric vehicle or anything electric on something that's on electricity that's made out of coal? Well, that's a good question. And I did some math to figure out whether that made sense or not. So is electrification a smart thing or a stupid thing? And I don't want to be the dumb guy and driving that's a picture of an electric car with a generator on the back for those of you that have a sense of humor. Sorry, I couldn't resist. Anyhow, if we purchase a brand new furnace, a standard furnace, and nearly every single furnace sold in Texas is an 82% efficiency furnace. There are some 90% plus condensing furnaces sold in Texas. But those of you that are inspectors know that having those in a non-climate controlled attic can be a big problem in a winter storm Uri environment where those condensing lines freeze. And therefore, Texas will continue to be an 82% furnace market for the foreseeable future. Anyhow, it's going to use about 36,000 kilowatt hours equivalent of gas at 82% to provide the manual J requirement of 30,000 kilowatt hours of heat in the course of 1 year. That's kind of a ballpark number for a house in Texas. And let's just go with the basics. Let's not worry about transmission losses and pipeline leaks and wellhead leaks and all that stuff. We'll just go directly to the combustion emissions of that gas when it's burned. And that's going to come out to about 0.15 kilograms of CO2 emitted per kilowatt hour. Okay. It would be almost double that if we added in all the other losses, but let's just stick with that. I don't want to overstate this. So 5.5 metric tons is where that comes out per year. And this is what it looks like if you use a heat pump with a COP of 4 to deliver that same 30,000 kilowatt hours of heat. The consumption of electricity is 7,500 kilowatt hours, and you end up with 1.1 metric tons, or roughly a fifth of what you get out of a gas furnace in terms of total emissions. So big difference in the emissions, and some of us in this part of the country are concerned with emissions. Some of us are not, but the example is pretty straightforward math. You can look it up at that link there and rerun the numbers if you like. I did get a C in multivariable calculus. Actually barely got a C, so you may want to check me. In any case, remember when I was talking about all that electricity being made out of coal here in Arkansas? Well, over in the United States, as a result of some changes to wind, a little bit of solar, and some nuclear improvements, and even some natural gas performance improvements. Been a 36% drop in the last 15 years in the amount of CO2 emitted by US producers of electricity. That's nationwide, right from the Department of Energy. That's a very hopeful thing, and I would not have predicted that. It's great to see that. And I expect from spending 40 or 50 hours a week studying these things, it looks to me like that's going to continue to improve. So not all happiness and sunshine in the future, but we are getting definitely better every year, about 2.5% every year. So there is hope. Other technology that's changing is refrigerants. Everybody remember a few years back, we switched from R22 to 410A because we had to get rid of chlorine. We went from HCFCs to HFCs, hydrofluorocarbons. Anyhow, we changed, and regrettably 410A had a higher global warming potential than R22, which became the big issue. And now we're switching to a new refrigerant. My company is switching to R54B pretty much for almost all our products. And that's what we call an A2L refrigerant. That product on the right is the very first one made in the USA with low global warming potential refrigerant, low GWP, we call it. That A2L refrigerant, some of you may be concerned with flammability and safety of that refrigerant. It is classified as flammable. If you want to go look at YouTube and dig around on the internet, you can see hundreds of examples of technicians and scientists and hooligans trying to make that stuff catch on fire. Let's put it this way, it's harder to burn than a dollar bill. So it's flammable, but only under very specific conditions. And if you simulate a leak in a system and try to fire it up, very hard to burn. In any case, we're switching to it. We don't have much choice. We're doing it right now. In the space of 1 year, every single one of our products will be switched over to A2L refrigerant, and that's all that we will be legally allowed to ship to our customers. So we've already started, and that's going on right now. There's a fun link there if you want to go in and do some reading. It's actually, even though it's a government website, it's possible to read it, and it makes pretty decent sense. But that's what's happening right now. And that's a big technology shift. And yes, some products may become more expensive, particularly furnaces and coils with conventional air conditioners and heat pumps. There are a lot of requirements for leak detection and evacuation. So that's something to be aware of. That's going to cost our consumers a little bit of money. We've been successful in geothermal heat pumps and managing that cost, so we don't expect a major increase in pricing, but there is cost involved. What about efficiency? Is one more efficient than the other? Yep. That chart on the bottom is, I pulled that right out of a brochure of what we call our 7 series product. If you go to pick closed loop or open loop and look at, say, your cooling EER, and you can see full load or part load. At 95 degrees Fahrenheit, you're probably at full load. You may be at part load, depending on how you size the equipment and depending on your water source, like how big your loop is. A very big loop with a slightly oversized, half-ton oversized piece of equipment will operate at part load at 95 Fahrenheit, and at full load, if the product is just barely at the right size and the loop is marginally okay, you'll be at full load. So anyhow, your efficiencies at 95 degrees Fahrenheit, 19.1 EER, all the way up to 55. That's a pretty good range, and that range is in the upper right-hand chart. You can see 17 to off the chart is the EER range. Again, EER is typically measured at 95 degrees Fahrenheit. And from what I saw last summer, 95 degrees is just where your problems begin in making enough electricity for air conditioners to operate. Comparing that to all air source heat pumps, like all sizes, all brands, several 100,000 ratings taken from the AHRI database. That's your orange curve right there. You can see they average out around 12 and a half, and there's a couple, like 3, that go as high as 15. That includes variable speeds, mini splits, multi-splits, VRF, you name it. And 5-ton systems down there at the bottom in the red, they don't quite make it as high. Some of you already know it, but as tonnage increases on a typical air source heat pump or air conditioner, your efficiency tends to drop off a little bit, maybe from 20 SEER 2-ton down to a 16 or 17 SEER 5-ton for identical products. So that's your efficiency range in EER. And again, EER is an instantaneous measurement at 95 degrees Fahrenheit. So that's high temperature performance, kind of full load for a normal air conditioner, either partial or full load for a ground source heat pump. If it looks like one is dramatically more efficient than the other, you are correct. There's almost no comparison in efficiency. That's where all of those savings, that $2,835 a year or whatever the number was, that's where that comes from, is that efficiency right there. And the same is true with heating COP. As high as 6, as low as 3.4. So if you say, for instance, it's 0 degrees in Dallas during a winter storm event, that heat pump there in the blue doesn't really care because it's not 0 degrees 30 feet below the ground. It's what it was in the middle of the summer. So using that heat source is very different from trying to heat with 0 degree air. And if there's any questions, I'm going to pause real quick. That's a lot to take on. I'm looking at the chat.
Yeah, I don't see anything in the chat,
Okay.
Will, but
Okay.
did have a question though. So I know you and I discussed this, and I kind of forgot what we had this what was we landed on with that. But with the new testing requirements to change the SEER to SEER 2 and the
Right.
HSPF to 2, did your
Yep.
data change for that as well?
No, ground source heat pumps are not affected because SEER 2, EAR 2, HSPF 2, those require manufacturers to test at, instead of the old system at 0.1 degree of external static pressure, it moved them up to 0.5 degrees of external static pressure, or 0.5 inches, excuse me, of water column for ESP. We test at 0.7 already. So AHRI ASHRAE decided not to impose SEER 2 on, or EAR 2 on geothermal, because we would have to lower our airflow testing standards instead of raising them. So that orange and that red curve that you see there on the left moved further left with SEER 2 and EER 2. So they got less efficient because they had to use more airflow, which means more electricity to the fan motor. So the EAR 2, SEER 2, HSPF 2 all effectively lowered the efficiency ratings of air source equipment and did not affect ground source equipment. That's a great question.
Yeah, no, thanks for that answer. That's impressive. Thank you.
Yep, good thing to know. Good thing to know. I used to be in the air source business, so we wondered how we got away with it for a long time. Controls. This is a homeowner with an iPad or something, or some sort of device, and he's looking at his house. At the very beginning, we saw that map of Texas with the 240 dots. This would be a guy with one of those dots. He has the monitoring system installed on his system, which in Texas is, oh, Brian Shaw may correct me, but probably 5 or 10% of our customers in the history of our business there have this system. So it's very few, very, very few, maybe even less than 5% in the last 30 years. We've been doing this for about 7 or 8 years in Texas, so it's fairly new there. But this guy has one of those systems, and he's able to see all the temperature. You can see, if you look, squint real close, how many watts his fan is using, and how many watts his compressor is using, whether or not his backup strip heat is operating, or if he even bothered to have strip heat installed, which most Texans would not. And he's seeing what his water temperatures are. He can call up his dealer and say, hey, man, my incoming water temperature in the middle of the summer is 90 degrees. That's too hot. You short looped me, buddy. So he can see that stuff, and it's kind of like being able to tell what your auto repair guy did to your car, which is a pretty good thing to have. So there's a lot of technology we're out there with now today. I will say that that's the homeowner view. The technician view is 100 times that much information, and they can look at it in any way that they like over the last couple of years.
Just a quick question. What would the solution be if said homeowner looked at that and said, you short looped me? What would a solution be?
The hard answer is you got to put another hole in the ground or dig another ditch and put in a little bit more loop. You could add a fluid cooler, which would be about the same price. Or you could, you could pursue other satisfaction with your dealer. That recently happened in a highly visible, famous person's house in South Carolina. The dealer short looped him and undersized the equipment because we felt it was important. We provided a new piece of equipment. He put in another loop, and we put that dealer on probation, and we can now watch that system every day to make sure that loop is performing properly. But, every now and then you got a contractor who wants to try and get away with a little bit less cost or do a quick, dirty installation.
Absolutely. Yeah. Does it matter about, I mean, I'm sure it doesn't with the technology we have for digging, but as far as the type of soil that's there, I know Texas has got the black gumbo, and sometimes it's extremely hard to dig through that.
Yeah.
That really doesn't affect how that's installed.
Yeah, we can actually tell you exactly, we can predict, I'm going to show you that software, how we can actually predict exactly how much you need to dig and how much pipe length you need and how deep. So I should probably skedaddle along, but we'll get back to that in just a minute. These are different heat exchangers. I think that's actually a picture from Texas on the left. That's slinky coils buried about probably 8 feet. Yeah, it looks like a 8-foot ladder, so maybe 7 feet underground, judging by the height of that fella. No, maybe more than that's a little taller than that fella. So yeah, somewhere around 8 or 9 feet. Yeah, ballpark. That's going to be a real good loop right there. I don't know what tonnage it is, but right next to that, you see a horizontal boring machine, just like the gas company uses to put their pipe to the ground. We do the exact same process as the gas company with the exact same pipe. We don't have yellow pipe or yellow stripe pipe. We use black or blue stripe pipe, but it's exactly the same high density polyethylene pipe. That's a picture of it in the top right. And that's a down and back or out and back U-turn at the end. And what you would do is, if you were boring, you would drill out 400, 600 feet, whatever you want to do, under that tree and under that house. You would grab a hold of that pipe, pull it back through, and then hook it up to your manifold and run your water through it. Very simple. That's the simplest, best solution for Texas. If like the oil folks in Texas, you want to drill vertically, that works really well as well. We can do 3 or 4 300-foot holes for a 5 or 6 ton unit, or you could do, and there's software to tell you exactly what you would do, or you could do maybe 1 500 or 600-foot deep hole with 1.5-inch pipe. So the size of the pipe, the depth of the hole, the type of the soil, the kind of water you use, we address all of that in our predictive software, which is really easy to use. Again, I mentioned the DOE report. That's pretty interesting to look at. This gives you the actual impact of if you do this much ground source heat pump, this is what an effect it has on the grid. If you caulk the windows and insulate the attics, it adds this much, and so on and so forth. That's all in that chart. Very handy to look at. The executive summary of this report is readable, and the rest of it's a pretty deep rabbit hole. But that's my job to read it. If you have any questions, let me know. It's not the best part of my job, but there is a link to it right there at the bottom of the page. New trend, I'm going to hop through this real quick. In the Northeast, parts of the Midwest, and even in places like Oklahoma, this is taking shape. These are geothermal districts where you can combine and share thermal energy with water pipes. They're all over the country. These are some locations, and these are some, interestingly, it's gas companies that are pushing this. Some gas companies just because they have environmental goals, some of them because, like in Vermont, you're not allowed to sell gas in 30 years, and some of them just because they want to try something different with the same pipe. Anyhow, that's who's driving this, is gas distribution and gas, well, just gas companies in general. And these are some of the locations you see on the right where they're taking place. Resources, I'm going to wrap up here pretty quick. Installer locators on our website there. I think Brian shared that in the chat. These are dealers that we work with. All our competitors have, I think they have locators as well. They may or may not be up to date. But Brian Shaw, who's on this call, is our local rep, and he makes sure this is up to date. When you see this logo, and our competitors, again, have similar certifications. Ed Miller Services Company and Willis Mechanical have extensive training. They do a significant amount of installations. They do lots of things to make sure that their systems are properly installed and their customers are happy. So they get that GeoPro certification from the factory. It's sort of like a Carrier FAD or a Train comfort specialist, same sort of thing. But that's where you can find all of our installers, and they can help answer any questions you have. Again, with the fancy circles. And GeoLink is that software I talked about. It's online. It's a free download. Brian can help you get that. You take your manual J, you plug in your load. This tells you, A, what equipment you need and exactly what size loop you need, whether it's horizontal, vertical, how many pipes, how big around, what kind of water you should use if you need antifreeze, which you probably don't in Texas, and everything you need to know. And it will also provide you a comparison with like a 14 SEER unit, a 16 SEER unit in terms of annual cost, and answer a lot of questions that you may have about how to install the equipment. So that's free. It's a download. By the end of this year, it'll be an online web app that you can use on a phone or a tablet, and you won't have to download any software. But again, all you got to do is hook up with Brian, and he can help you get that software too. And that's really sizing equipment, sizing software, and loop sizing software. Just want to touch back. After you use this, if you use this properly and you put in the right location, like South Texas, we can go back and confirm your results with that Symphony Controls software and make sure that you got what you paid for. Pretty cool. This is that Symphony Controls software that tells us exactly what we need to know about your job or your installation. Again, zooming into Texas, we can tell that house right there. What city is that? Is that Woodlands, maybe?
Yeah, just looks like south and west of Houston. Yeah, south, actually
Maybe.
northwest or just west.
Okay, maybe somewhere up one of the cedars. That's a 5-ton variable speed ground source heat pump. You can see they're heating to cooling ratio is about 1 to 10. They run their fan just a little bit. Well, that may be a lot actually, because that fan only uses about 60 to 100 watts if the filter's clean. So they're effectively heating and cooling their whole house for about almost $2 a day, and that's 12 months a year. I know that when I lived in East Texas in a 4-bedroom house with a 5-ton air conditioner, I'd have been happy with a 936 just for the month of July and August. But that's 12 months energy usage. So that's helpful information for you guys and people all over Texas. This is the before you install savings calculator. We looked at that, different houses. There's a house near me in Arkansas, 1853. Our utilities are a little bit cheaper here than Texas, and the house is a little bit smaller than the ones I showed earlier. So the savings aren't quite as great. But that's available to you. There's the link to it. All our competitors, again, I'm not selling water furnace. This isn't a sales pitch, so I want you to understand that this is a common tool for all of our competitors. In geothermal heat pumps, you will not get this for anything outside of geothermal heat pumps. And if you do, it's going to be a couple of dollars here and there. So what we want to do in our industry is call out the dramatic savings impact once you install this equipment. Y'all want to come up to Fort Wayne, Indiana? We love to have visitors. We can do training. We've trained installers. We've trained inspectors. We've trained HERS raters on the equipment and how it should be installed. You see our residential lab on the left, our installation device that plugs into the unit. And there's the commercial lab there on the right where we do testing and training. We'd love to have you come see it for yourself. It's a single hop from DFW right to our backyard. We're right next to the airport in Fort Wayne, Indiana. This is a picture of Brian Shaw. He's not nearly that good looking, but it's a hell of a good picture. That's his email, that's his LinkedIn, and that's his phone number if you want to call him on Sunday night. Sorry, Brian.
He's laughing in the chat.
Yeah, we are in Texas, and Brian is a terrific resource. Our contractors, you know how to get a hold of them. They're easily to get a hold of, and Brian is as well.
He says he welcomes calls 24/7.
24/7.
So take him up on it.
I'm going to get a letter bomb wrapped in anthrax next week, but there it is right there.
Nice. So we had, just real quick before we jump to my screens, there was 2 things posted. Actually, we just had another one drop, but just real quick, this is kind of more of a comment. He said, I've seen the blue underground air distribution here in North Texas, and they had problems with water intrusion. They had to dig it up and put pumps in to pump out the groundwater. Have you seen anything like that?
Well, these are high density polyethylene pipes that we've been using for about the last 20 years. And again, it's the exact same pipe that the gas company uses. It should be sealed, and the weld joints in the pipe are actually stronger than the normal length of pipe, because they melt the pipe together and it fuses into a single piece of plastic. The gas companies in Texas use an 80-year depreciation cycle that the bank approves in order to borrow money. So if those pipes don't last 80 years, the bank doesn't back those loans to the billion-dollar loans to the gas company. So there's a lot at stake here. We have in the past offered a 55-year warranty on this pipe. I saw something there about the color blue. 30 years ago, maybe folks were using some sort of blue pipe or PVC pipe, and there were problems and leaks. It was a problem. We converted over 20 years ago and haven't experienced that since. We're fine in earthquakes. The things we worry about are backhoes and idiots, and 811. So if that's a good enough answer, I'll jump to Mark's question about if everyone did it. I guess the answer to that is it wouldn't really matter. The one cautionary note is if say you're drilling 300-foot holes, you want them at least 10 feet apart, because if you have a long, hot summer, they can't, that 5 feet radiation from each pipe can overlap. So you want 10-foot spacing minimum as you get down into the ground. And if you have a lot of pipes, it's not really going to affect the planet. Every single air conditioner in the world could be a ground source heat pump, and it wouldn't really affect the planet at all. You saw that small 2.5-acre lake is thriving after almost 40 years of heating and cooling that building and that laboratory. It doesn't really. Now you can overheat a loop if you don't have enough pipes in the ground. You can get it so hot in the summer that it'll take all winter to recover. That's bad. That just means you didn't go deep enough, or you didn't put enough holes in the ground. You didn't use the software to figure it out beforehand. And there was an old wildcatter in Oklahoma who used to put in what he sold as 300-foot loops with 300-foot pipes, and behind his workshop he had a pile of 50-foot cutoffs. He was short looping everybody, and he is no longer in business. But yeah, there's criminals in every field of activity. But if they're doing what they should do and they're following the design, it's kind of like improperly charged split systems. There's guys doing that all the time. It's our job to ensure that they don't, through training and enforcement. So I'm really happy to have you guys on the phone here today.
Absolutely. And you spoke a little bit about this in the very beginning. I'm not sure that you can answer it specifically, but Jorge actually asked average install cost for a 2,600 square foot home in DFW.
I missed that.
So,
Yeah. I'm gonna let Brian put something in the chat. I think his microphone's disabled, but Brian, if I were to say $60,000 for that, that would be a 3.5 ton on a modern home.
I can turn his out. He's allowed to talk now. He can just unmute his mic.
Okay. Before the tax credit, just a replacement without duct work, where would you put that? I guess I'm not sure he's got his microphone turned on, even though we allowed it.
There he goes.
Okay. Sorry about that. As far as the question on budgetary for a homeowner, we've been hearing anywhere between 10,000 to 15,000 a ton, which includes the ground source to the equipment, the installation, labor, tax, all that good stuff. So it also depends on what series, what performance equipment you want to go with. So that's kind of what I've been hearing with my contractors at the different trade shows I've attended and helped out with. So, but yeah, that's the kind of the going rate. Anywhere between 10,000 and 15,000 is a soft budget.
So a $60,000 4-ton would be a high-endish thing, and
Yeah.
And then you would add a 30% tax credit to that, which would be $18,000. So that would lower it, down to closer to 40. I will say that as the volume increases in any given area, the prices go down. In Missouri, the costs are about half that. But in parts of Missouri, just about everybody's getting the ground source heat pump in some areas. So, the loops and the installation are much, much lower cost. I would say that in Massachusetts and New York, it's much higher. So, God bless Texas, your prices are still pretty reasonable. There's a question about warranty. Most air source units, as you know, come with a 10-year parts only, and sometimes people will buy a labor warranty. Almost all ground source heat pumps come with a 10-year parts and labor, just out of the box. Some folks negotiate that down or buy a lower warranty, but pretty much the standard is 10 years parts and labor.
Perfect. All right. If there's any other questions, feel free to ask them now. Otherwise, Guys, I appreciate you guys being on the call. Will, I appreciate you being on here. Brian, thanks for jumping on and being able to put some things in the chat.
Yes, sir.
I've learned a lot of new things today about the heat source. I mean, I've dealt with heat pumps before, but not really the ground source stuff. So that's fantastic information. I appreciate you guys being here.
Terrific. Randy, I'll send you a PDF of this presentation with all the links and none of the animation. And you can do whatever you want with it.
Yeah, we'll take that and probably send it out with our email survey.
Okay.
And that way everybody will get a copy of this. But thanks again for that. I appreciate your time. Thank you very much. And
Pleasure.
guys, appreciate it. Have a good week. And we'll see you on the next webinar. Thank you.
Thank you,
Awesome.
Randy.
Thank you.
Thank you.